Hello, in this video, I will be explaining about some data analysis strategies that you might need to do to analyze the data that you have collected for your research. Okay, so first thing you need to do is data entries, especially if you have a paper-based questionnaire, you will need to enter your data into a spreadsheet or SPSS directly. And even with the online survey, you might only get a list of your data in an Excel spreadsheet, and you will want to copy paste or export your data into an SPSS data file. One tip is to remember to assign every subject to a subject number. So yeah, you can see in here in the first data that there's like subject identity. So this is important to have a subject ID because perhaps you might need to some special treatment for a particular subject. Maybe you need to delete the data because it's incomplete or something. Yeah, so you will remember which subject ID that the data is being deleted, and make sure all of the variables are labeled based on the data type, yeah, the nominal, ordinal, or scale. So here, yeah, the interval data will be labeled as scale, and the nominal ones is the categorical data, and ordinal measure is the rank order thing. So remember, nominal is categorical, ordinal is rank order, and scale is anything that's continuous or interval data. Here's a data entry tutorial that you might want to look at. Okay, the next thing you want to do is analyzing the descriptive statistics of your data. One thing you can do to get your descriptive statistics of your data is by using frequencies. In SPSS, it's here in Analyze. You click Analyze and then Descriptive Statistics and then Frequencies. And then you put in the variable that you want to get the descriptive statistics. For example, in here is the device owned. And then you want to get some typical central tendencies that of your data of the variable. Here mean, median, mode, and standard deviation at least that you want to see. Okay, so here is the output that you will get from the frequency analysis. The first table you can see here is the central tendency table. You can see the mean, median, and mode here. And then the second table here is the frequency table itself. You can see the exact frequency of each of the device owned by the participant, and then the percentage, relatively to the ones without missing data. So the missing data here is not counted here, but the valid percent is only counting those that are not missing. And cumulative percentage is basically summing up, between the categories. Tablet and Mac make up 17.6%, and then tablet, Mac, PC make up into 83.8%, and so on. Okay, if you want to get more descriptive statistics of your data, then you will click Descriptive. So this is below the frequencies. Here you can again put in your variable that you want to see the descriptive statistics, and then click Options here. And in here you can get some central tendency as well, means, standard deviation, minimum, maximum, but without frequency table. This is the output that you'll get from descriptive statistics analysis. Next is the assumptions test. So there are at least 2 assumptions that are required to be met before conducting further analysis, further statistical analysis. The first one is normality assumption. This is to evaluate whether the data is normally distributed or not. Normality is required for some statistical analysis, for example, the t-test, ANOVA, etc., regression as well. Normality test assumption tutorial, you can find it here. And for the linearity assumption, this is to evaluate whether the data is linear, required for Pearson correlations and regression analysis. If it's not linear and not normally distributed, then you will use non-parametric analysis that's use Spearman correlation. And you can see the linearity test tutorial here. So how to do normality assumption test? You can click in Analyze, Descriptive Statistics, and Explore. And this is especially for your dependent variable. So if you are comparing between means, so if you have, if your independent variable is a categorical data, then you will put the categorical variable into the factor list. Then your dependent variable will be in the dependent list. If you have correlations or regressions, so at least the both independent and dependent variables will be continuous variables, then you will put all of them into dependent list. Then you click plots on the right hand side, a new window pops out, and check none for the box plot options here, and uncheck everything for descriptive, and make sure the box normality plots with test is checked. So this is the only thing you need to check here. And this is the output. Okay, so here you can see there's the test of normality. Yeah, and if you see the Kolmogorov-Smirnov or Shapiro-Wilk data shows that the significant level is greater than 0.05, then the data is normally distributed. Basically, if it's not significant in both these tests, then it means that your data is normally distributed. So that's great. Then for the linearity assumption test, you click Analyze and then Compare Means and then click Means. Then here, for example, your dependent variable is hasil belajar, the achievement score, and then the independent list is motivation. And then you click Options, and then in here, yeah, you click the test for linearity and then click Continue. And this will be your output. And what you will want to check is this one, the deviation from linearity. Yeah, and again, if the deviation from linearity is not significant, which means that your data is linear, yeah, because it's not deviating from linearity. So if the p is greater than 0.05, then it's not violating the linearity assumption. Then it means that your data is linear, and that's great. You can continue to do further statistical analysis. And then next is correlations. There is a correlational analysis tutorial here as well that you can also watch. So correlational analysis is statistical technique to test relationships between two variables. Most of your survey research plans are going to use this correlational analysis. There are two ways, yeah, to do correlational analysis. The first one is the Pearson's product moment. This is based on the computation of the raw numbers, and this is used for continuous data. It is a parametric statistics, which means that this is more robust than the non-parametric statistics. It's used with larger sample and has parameters such as mean and standard deviations. But for the Spearman correlation, this is a type of non-parametric statistics. It's used for non-normally distributed data. And here, instead of being treated as continuous data, the data is treated as ranked. Yeah, so it's kind of like violating your own type of level of measurements, because your data is supposed to be interval or continuous data, but then because of some assumptions that are not met, for example, the normality assumption, then you will have to treat this continuous data as rank. So yeah, no normality assumption test is needed, and it can be also used for smaller sample. For Pearson's correlation, you click Analyze and then Correlate and then select Bivariate. And then because it's bivariate correlation, so you put all of the independent and dependent variables into these variables, and then don't forget to click Pearson, because if your data is normally distributed, then you will choose Pearson. And test of significance, if normally we will choose the two-tailed, because we don't usually always have the direction of the correlations yet. And then click OK. This is the output, yeah, of the correlation or Pearson correlations analysis. And in our example here, we are correlating between math and music variable, and you can see here that there is this minus negative 0.900, and there are like two stars here, two asterisks. The same in here. So both these scores are showing the correlations between math and music, that is, the coefficient is negative 0.900, negative 0.900, and the two-tailed significance of the probability level is less than 0.001, because it's written here 0.000 or less. So the correlation is statistically significant. So we can say that there is a strong correlations between music and math. And here, the n here, 10 here is showing the number of cases, or your sample number. So the number of cases on which this correlation is based is 10. This information is also given in this cell. So this basically these two columns are showing the same thing. So this is how to report correlational results. We can see that the correlation between math and music was negative 0.90. The significant level was 0.000, which will be reported as the p less than 0.001. The degree of freedom is n minus 2, which is 8, yeah, 10 minus 2. And then this is how you report the results. There was a significant negative correlation between musical and mathematical abilities. R is the correlational index, yeah, correlation index or correlation coefficient, which was the negative 0.90, df equals to 8, and p is less than 0.001. This result shows that children with higher musical abilities tended to have lower mathematical abilities. And then another type of analysis that you might need to do in this class is independent sample t-test, and you can see the tutorial here. So t-test is used to compare between means of two data sets. So if you have more than two data sets, then you will use ANOVA, not t-test. There are two types of t-tests, yeah, the dependent sample t-test. The two data sets are obtained from the same sample. So for example, you're comparing between the pre and post-test score. So this is called also the repeated measure. So you will compare the within subjects. Yeah, so the design will be within subjects. So some of you are going to collect data twice from the same sample. Then you're using dependent sample t-test. And then the second type of t-test is the independent sample t-test, in which you will have two data sets that are obtained from two different samples. So for example, you want to compare between male and female students, between one batch and another batch. So you are using the between subject design here. So this is how to do the unrelated t-test or independent sample t-test. You click analyze and then compare means and then independent sample t-test. And then step 2 here, you will put your dependent variable in the test variable. Here in this example is the emotion. And then you will put your grouping variable or your independent variable in the family. In the grouping variable. In here, the example is family. And then you will define the groups, yeah, of the independent variable. So here in the define group box, you specify the value. So if you have two labels, you have two groups, then you will label group 1 as 1 and group 2 as 2, and then you're basically just telling SPSS you have two groups. Yeah, the group 1 is coded as 1 and group 2 is coded as 2. And then this is the output of the independent sample t-test. The first table shows for each group the number of cases, the mean, and the standard deviation. So you're basically seeing the descriptive statistics of each of the group. And the mean for the lone parents, this is, for example, two types of family. One is the lone or maybe single parent. Yeah, it's 9.5. There's obviously a difference, therefore, between the two types of family. The question next is whether the two means differ significantly. So you can see here the family group number 1, or maybe the lone parent or the single parent, the mean of emotion is 9.5, and then the group number 2, the mean of the emotion is 13.42. So superficially, we can see that there might be differences between these two groups. Okay, so this is the independent samples test output. You can see the table here. In the first two columns, you see the Levin's test for equality of variances. You want to get non-significant result here. So if you get non-significant result here, it means that your data from the two data sets are equal. So homogeneity assumption is met. So if it's non-significant, then you will see the results of the t-test. Yeah, the first row here. Yeah, so you can see the significant level here is 0.011, and the t-test score is negative 2.81. But if you get a significant result for your Levin's test, then what you will see is the second row here. Yeah, it means that the homogeneity assumption is not met. But you can see here in this example, the both showing a significant result, yeah, a significant difference between the two data sets. So in this case, it doesn't really matter. And this is how you report the t-test output. So we can see the emotionality mean of the children in two-parent family, the group number 2, was and then you have to mention the mean and the standard deviation here, yeah, in parentheses. Was significantly higher than children in single parent family, and again mean and standard deviation, and comma the t, and this is the df, yeah, the degree of freedom 20 equals to negative 2.81, and then the two-tailed p level or significant level equals to 0.011. So the APA guideline says that when your p level is above 0.001, then you write down until 3 decimals, so the exact p level. So that's, but if your SPSS shows at 0.000, then it means that you are writing it in as p less than 0.001. The next, the difference on emotionality score between the children in two-parent family and children in single-parent family was negative 2.81. The 95% confidence interval for this difference is from negative 6.82 to negative 1.01. This difference is significant in two-tailed level 0.05. So this is the more elaborate, yeah, results that you can write in your report. Okay, that's it for the data analysis.